Voyager 1, a look back at the spacecraft's 40-year journey. The Voyager program has truly revolutionized our understanding of our solar system. To think that this program is functional to this day is completely outrageous. The Voyager's program was launched back in the 70s and continues to work even when the probes are billions of miles away from Earth. In this video, we will talk about the evolution of the Voyager 1 program and the contributions it has made for humanity at large. But before we continue further, I would request you to subscribe to the channel. Thank you! To date, Voyager 1 traveled almost 15 billion miles into space, and thus making it the human object with the furthest range. Right now, Voyager 1 has reached beyond the confines of the solar system, into the interstellar region. From its humble origins back in 1977, with technology which continues to transmit knowledge even today with all the dated infrastructure, it is truly amazing that Voyager 1 has continued to function even today. Voyager 1 entered interstellar space in August 2012. However, this finding did not reach the public until 2013 when scientists analyzed the data which was sent by the probe. The Voyage mission really benefited from a special alignment of all the planets in outer space, which occurs once every 176 years. Due to this alignment of the planets, probes could slingshot from one planet to the next, which would be the best application of its limited fuel resources. Originally, NASA planned to send 2 other probes for Jupiter, Uranus, and Neptune. Budget constraints had forced NASA to limit itself only to 2 probes. NASA had put 2 golden records on both its probes. These golden records consisted of a 12-inch gold-plated copper disc, which would be used to capture the diversity of sounds present in our planet, including 55 languages. The reason why these golden records were included on these probes was to give some form of acquaintance to any intelligent extraterrestrial life which happened to have access to these probes. There was other information recorded on that disk, as well as such illustrations on how to use that disk, as well as the location of our sun among the nearby pulsars. This was done to give these extraterrestrial aliens a kind of map to our home, which is not the most inviting thought, now come to think of it. Voyager 1 and 2 are powered by 3 radioisotope thermal generators, which produce energy by converting plutonium's heated decay into electricity. All in all, both these probes have about 10 scientific instruments. These instruments included a 2-camera imaging system, multiple spectrometers, magnetometer, and detectors for low-energy charged particles and high-energy cosmic rays. Voyager 1 almost failed in its launch, as it had only 3.5 seconds of fuel left, but thankfully, it was able to reach space safely. Voyager 1 was also able to go beyond the main asteroid belt between Mars and Jupiter before Voyager 2. Voyager 1 was the probe, which got us the first detailed images of Jupiter. Many more discoveries were also made, such as the discovery of a fine ring around the gas giant, as well as 2 new Jovian moons, including Teba and Mattis. Voyager 1 also discovered that one of Jupiter's moons, Europa, is also likely to contain a massive subsurface of liquid water which can support life. All of these discoveries were made when Voyager 1 was at its closest to Jupiter, at about 174,000 miles. After that, the probe was directed towards Saturn. Detailed images of Saturn could only be obtained in the next year by 1980. Voyager 1 was again able to show the gaps in our knowledge about Saturn. On Saturn, Voyager 1 was able to detect 5 new moons in a new ring called the G-ring. Voyager 1 also discovered the second largest moon in the solar system, called Titan. Titan was shrouded in secrecy before that, because it was covered in an orange haze. When Voyager 1 approached Saturn, it was able to complete its primary mission. The next order of business was to go further beyond any human had gone, deep into interstellar space. However, before that, Voyager 1 produced one of the most iconic images to date, when it captured the image of our planet Earth from a distance of 3.7 billion miles. The picture came to be called the pale blue dot, signaled how tiny Earth was, and it frankly is a very humbling experience. Voyager 1 broke out of the heliosphere, and the discovery was made in 2013 when the Voyager's instruments recorded a powerful solar eruption. The oscillations recorded show that Voyager 1's surroundings had a higher density than what was inside the heliosphere. That may seem contradictory at first, but scientists were able to explain that the electron density is significantly lower than the Earth's surface. After combing through Voyager 1's data, scientists were able to trace the official departure date back to August 25, 2012. This determination was made by measurements of charged solar panels taken by the spacecraft. Since entering interstellar space, Voyager 1 has so many more discoveries about this region of space. For example, we have for the first time came to know how charged particles from the sun interact with other particles emitted from other stars. The most surprising thing about Voyager is how robust its technology is. Voyager 1 was able to use its backup thrusters to orient itself so that it can relay data effectively to Earth. These thrusters were not used since 1980, when Voyager first had to fly across Saturn, but as the attitude-adjusting thrusters decreased in performance, NASA wanted to try TCM thrusters, which had the capacity to increase the life of Voyager 1. The test for using TCM thrusters was successful, as the probes made it into the interstellar region. Some of its scientific instruments had to be turned off to preserve energy. This means that Voyager 1 has 4 operational scientific instruments, including the cosmic ray subsystem, the low-energy charged particles instrument, the magnetometer, and the plasma wave subsystem. All of these instruments will help scientists in getting a better understanding of our galactic neighborhoods, as well as provide newer insights into our very own solar system. One important question about Voyager's capacity is how it is able to relay data back to Earth despite the huge distances. The spacecraft is able to send information, including pictures and sound bites, using the Deep Space Network, or the DSN. The DSN consists of big radio antennas, which are located in different parts of the world. Exchange of information through these radio antennas is a huge accomplishment on its own, since it takes more than 20 hours for data to reach from the probe to Earth and vice versa. The radios on the Voyager utilize 23 watts, which pales in comparison to the tens of thousands of watts sent out by the radio antennas around Earth. Despite their strength, these signals still fade out very quickly. This means that the solution to receiving signals in outer space depends on having extremely large antennas, which have directional antennas that are pointed at each other and radio frequencies that are free from man-made interference. The antennas used by the Voyager probes are also quite large, which are up to 3.7 meter in diameter, which transmits to an antenna which has a 34 meter diameter. The comparison with your average cellular antenna is kind of meaningless in this case. The other big difference is that the Voyager satellites transmit in the 8 GHz radio frequency, which is free from human interference. This enables the Earth's antenna to use an extremely sensitive amplifier to make out the faint signals sent out by the probes. The Earth antennas then use extremely powerful antennas to send out these powerful radio signals, which can be received by the spacecraft. This is how NASA's DSN, or Deep Space Network, actually works. It makes sense then that it is the world's largest and most sensitive scientific telecommunications system. With the discussion of DSN and Voyager probes, we conclude today's video. I hope you found something of value in this video. Please hit the like button if you do. Thanks for watching this video till the end, and see you in the next one.